All right. Some slides up there. Great. Hi, I'm Jeremiah Lee, and I'm on Twitter at Jeremiah Lee. I'm so honored to be here with you today. This is my first trip to Brazil, and I think it's totally awesome that I've gotten to come to Brazil to talk about two of my passions, and that would be health and technology. So I live in San Francisco, California, and for the last 3 years, I have had the best job. I am a software engineer who is responsible for the Fitbit Web API. And I've gotten to speak at conferences all over the world about API design and developer experience practices, but I've actually never been allowed to talk about how we make the Fitbit Web API before. So you are the first audience anywhere to ever hear this presentation. So I have my speaker notes with me. Please forgive me. I had to 3D print my text file. In case you haven't heard of Fitbit before, Fitbit is the global leader in activity trackers. So we also have a Wi-Fi connected scale, and we have an interactive workout product called FitStar. The company is about 9 years old, and we sell products in over 60,000 stores in over 63 countries. But Fitbit's mission is actually much bigger than just putting a gadget on people. We consider ourselves a personal health and wellness company, and we just happen to use technology to achieve that goal. And the products seem to be working for a lot of people. At the end of 2015, we actually had over 29 million Fitbit users. Just an enormous growth. So today, I'm going to be talking about how you scale things, how we scale the Fitbit API. And I'm going to break that down into 3 areas. The first is product strategy. This is what should we build and for who? The next is organization scaling. This is how do we grow an engineering team that is both creating APIs as well as an engineering team that is using those APIs. And then we'll talk about technology transitions. It's how do I fix things when fixing things means getting a bunch of clients to make changes. So let's start with product strategy. Fitbit's Web API was created in 2010, and then it was released in 2011. I didn't join the company until 2013. And when I joined, I was the first engineer whose sole responsibility was to work on the Web API, which is kind of surprising. The company only had about 150 people at that time, and the API had been around for 2 years at that point. And I was asked to go figure out what should we do with the Web API. And I thought about this quote, seek first to understand, then to be understood. Seek first to understand, then to be understood. Because I've heard about how companies like Twilio and SendGrid and Stripe, they built these amazing API products. But it didn't seem to me that the strategy that they had adopted and what I had studied really would fit for Fitbit. So before I could determine a strategy for the Fitbit Web API, I needed to really understand what had come before me in the company. I needed to understand the business decisions, the product decisions, the current use cases of the API, and what are the future API integrations that we really wanted. This is the blog post announcing the Fitbit API in 2011. And I love this part of it because it shows that Fitbit really didn't know what the Web API was for just yet. What kind of stuff? Well, hard to say. But we hope to see things like visualization tools, cool logging services, and ways to import data from other sources into Fitbit. Note the typo. So by the time I got to Fitbit, who ended up actually using the Fitbit API? Well, for starters, maybe. Fitbit uses the Fitbit API. 7 months after the Web API was introduced, Fitbit introduced its first mobile application, and that was for the iPhone. And today, of course, we have applications for iPhone, Android, Windows, and a Mac OS X syncing client. We don't really have an API-first mantra. I know that's something that a lot of people have talked about, because we really try to design product experiences first, and then design generic data models to power those experiences. And we do that for an intentional reason. Our general thinking is that we want to share any capability inside of our own application with third-party developers if there's a reasonable way to extend that experience. We have a few exceptions, things like account management. We really don't want other people messing with people's accounts for security reasons. And Bluetooth syncing. It's really complicated, and third-party developers really don't want to have to deal with that. But for the most part, if you see it in our app, you could recreate that feature. Another use of the Fitbit API by Fitbit is this product, which we don't really talk about. We don't talk enough about. It's called Fitbit Group Health. And it's kind of like Fitbit for your office. So you can have all sorts of team competitions inside of your company. And this product now has over 1,000 enterprise customers. One of the biggest last year was Target, which is a major US retailer. They have over 300,000 employees, and they gave all of them a Fitbit tracker. So they're now using the Fitbit Group Health product to help inspire their workforce to be more active. But Fitbit's not alone in this sort of product. We actually work with all sorts of corporate wellness partner applications. And the web API enables these sort of integrations. And what's great about all of these integrations is that all of these companies are now selling Fitbit products into companies that we couldn't get into. So what this means is that the Fitbit web API has now enabled an entire retail channel for the company that's growing, and it's awesome. Let's talk about more traditional integrations. This is the Strava integration. For those who don't know, Strava is the top cycling, running triathlete application. It has all sorts of really great data features. And our integration with Strava allows you to take all of the data coming off of your Fitbit device and sync it over to Strava's really great social network. So it's nice to see that little run there. Another type of integration is one that we introduced with Walgreens. Walgreens is a pharmacy in the US. It's a large pharmacy chain. And they have a customer loyalty program. And this customer loyalty program is fairly standard. You buy stuff and you get points, and then those points become discounts down the road. Well, when Walgreens started selling Fitbit products in their store, they had this idea. Wouldn't it be cool if we could give people a few extra points in the customer loyalty program when they meet their daily step goals? I think it's pretty cool. So that's one of the integrations. Another would be connected devices. This is one of my favorites. This is called the Thermos Smart Lid. And what's cool about it is that this is actually Bluetooth enabled. So every time I take a sip of water from this bottle, it actually updates on my phone that I've taken a sip of water. And what's cool about this is that after I finish a bottle, it will automatically log it to the Fitbit application. It's a really great product. It makes water logging absolutely effortless. Connected home. Does anyone have one of these? Amazon Echo? Oh, I love this thing. So for those who don't know, the Amazon Echo is a speaker with artificial intelligence. So you can say things like, Alexa, ask Fitbit how I slept last night. And it will say, you fell asleep at 10:55 p.m. and awoke at 7:05 a.m. You met your sleep goal of 8 hours. Thanks, Alexa. I love this device. It's really cool. Anyways, and it's a very popular skill. A whole other class of people using the Fitbit web API are scientific researchers. So Fitbit has been used in over 100 academic research projects so far. Some of those have been done by the Mayo Clinic, Johns Hopkins, and recently we just announced a partnership with the Dana-Farber Cancer Institute. This is a really cool study that is going to look at the impact of physical activity and weight loss in breast cancer recurrence with study participants by using all the Fitbit products, the Charge HR, the ARIA scale, the FitStar interactive workouts. And it's a really great study. We'll see how that goes. And one of the great products to come out of this to enable researchers to use Fitbit products is Fitabase. So most researchers, they're very good at science, but they might not be very good at programming. So what Fitabase does is make it very easy to get data out of Fitbit. And many of these studies have hundreds or thousands of participants that may be in a study for years. So this product can also do things like compliance to make sure that people are actually staying active in the study. They're charging their device, they're syncing regularly. And then you get to export all of the data in aggregate. One of my favorite users of the Fitbit Web API would be individuals. Fitbit has a ton of users who just want to play with their data. So we like integrations that enable people who may not be programmers to take advantage of the Web API. And one of those integrations is with if this, then that. It allows people to complete a simple sentence. For example, if I haven't met my step goal by 3 p.m., send me an encouraging text message. And one of the most popular recipes on IFT is, at the end of every day, send my data to a Google Docs spreadsheet. It makes it very easy for people to get their data out of Fitbit and do something with it. So this is how the Fitbit Web API is being used. What is the strategy that you can get from that? First of all, our strategy is to support our own apps. Fitbit is the biggest user of the Fitbit Web API. Next is support apps that enable us to sell more products. So in the case of our corporate wellness partners, the Web API has created an entire retail channel that did not exist before. We want to support apps that enhance our product experience, because if we find more ways for our products to be useful for people, they're going to stay users of our product longer. Support apps that validate our product, like scientific research, just trying to see can we measure activity level and have positive health outcomes. And lastly, support data portability for individuals. Now you might notice what is not on this list. First of all, we don't sell user data. We don't sell user data. We believe that people own their data. So you won't see us selling user data as part of our strategy. The other thing is we don't really sponsor hackathons. It's not really a marketing technique that would work well for Fitbit, because hackathons, while a lot of fun, don't really do the sort of business development that we would typically expect from the rest of our API strategy. It's a little different. So that's a little bit about the Web API strategy. Now I'd like to talk about scaling. What does it take to actually scale a Web API? Over the last 3 years, the number of API requests coming into Fitbit has increased over 10x. This is absolute crazy growth. But I actually think the bigger challenge is not technology in scaling the Fitbit API, but it's figuring out the right processes and people inside of the company. I mentioned that when I was hired, I was the only person working on the Web API, but now we've hired a bunch of great people because we're a growing company. Here are some of those fine folks. We call ourselves the APIrates, which I hope that joke translates over. But I want to talk a little bit about how we structure our teams. So Fitbit has 2 types of teams. One of them is called a feature team. And a feature team is comprised of a product manager, a designer, a tech lead, an Android developer, an iOS developer, a Windows developer, a web developer, an API developer, and a QA engineer. We call this a full stack team, right? An example of this would be our sleep tracking team. So that team has every skill that is necessary to bring sleep tracking to market in all of the Fitbit product experiences, because we have all of those skills on a single team. And we have a lot of feature teams like them. But eventually these feature teams who've created all of their great features have to come together and ship a single binary. So for example, if you're an Android developer, you have to go talk to all of the Android developers on all of the feature teams to get their code together and then ship a single binary to the Google Play Store, right? So we call those type of teams component teams. And similarly, we have one of those for the API. This is this team. This is the API infrastructure team. This is my team. And we build things that are needed for API developers on all of the feature teams. So an example of that would be OAuth and rate limiting and client management and testing frameworks, right? All of the feature teams are going to need those things, so we have a team that provides those for them. We're a support team. So this means that we have people making APIs all over the company now, which is great. But we need some sort of coordination. And my strategy on coordination, part one, has been make it easy to create the right thing. And this is, I can start with some basic things, like documenting the style of the API, so that when you start to use any particular API, it doesn't feel like it was built by one of the feature teams. They all feel uniform. But you really need to do more than that. Something is only easy if it is obvious, and things only feel obvious when it comes from intuition. And intuition comes from empathy. Say that again. Something is easy if it is obvious. Something feels obvious when it comes from intuition, and intuition comes from empathy. So API developers need to understand what end users as well as users of the API need in order to be successful. And this means that API developers need to be engaged in the product development process. So I've talked a lot in the past about bringing UX, user experience practices, to engineering teams. So if you want to check out any of that information about my developer experience work, go to my website, dx.jeremiahlee.com. But I'll talk about one thing that's worked really well. And I've done this at multiple companies now. And I make API engineers do customer support for at least a few hours every week. Because when you have people who are using your API, those users are developers themselves. So we have an opportunity to create empathy from the developer who created the API with the developer that's trying to use that API. And this makes API developers understand problems that people using the API have. And from this, we've kind of come up with two mottos. One of them is, if two people fail at something, this would be people using the API, fix the system so a third person doesn't. This means that if you have multiple people who are struggling with the same problem, you now have enough data that you should go fix your documentation, or perhaps you might fix your API design. Like, there's a problem. Another one is, if two clients have to do the same workaround, the server should probably do it. Sometimes I've gotten into debates with engineers about a particular API design, and their only justification for that design is, well, it's easier for me to build the API this way. And I don't think that's a very good answer, because I really don't care how hard it is to build an API. What I care about is how easy is it for the client to use the API. If you have something that's going to be hard, put that hard thing on the server, because you're going to have multiple clients using that API. And instead of experiencing that hard thing for every single type of client you have, you only experience it once because you fixed it in the API design itself. So make it easy to create the right thing. The second half of that is make it hard to break anything. Make it hard to break anything. I hang the Linus Torvalds quote in my team's workplace, which is, "We don't break user space." Right? When you're an API, it's more important to do something correctly than quickly. I remind my team about this often. So how do you make it hard to break something? This has a very engineering answer, which is tools and testing, of course. I have a lot of ideas on this, but one of the best ones that I've come across is Swagger. Out of curiosity, how many people are familiar with Swagger, the Open API specification? Okay, so quite a few people. That's great. Swagger is an API definition format, and it's a machine-readable format, and you define all of the inputs and expected outputs from a particular API. And once it's in this machine-readable format, you get a lot of tooling that a community has created for free. And so one of those things is like an API Explorer, right? So you can make it easy to test an API before you have to write any code. But one of my favorite ways of using Swagger is actually as an integration test. What I've seen is that you have good developers who are practicing good code hygiene, and they go in to refactor some code. And as part of refactoring that code, they rename things. They might change how data is handled around. And they may unintentionally change the response object in an API. This is terrible. You're doing good things, but you're also breaking all of your clients. You've broken the API contract, and that's something you can't do. So the way that you can use Swagger as an integration test is to verify that all of the outputs from an API response actually match what you've manually documented. I do not automatically generate Swagger because I want it to be like a checkpoint that you haven't accidentally broken anything. It's a really great format, has a lot of advantages. Definitely recommend that you check it out. It's a great tool for hardening your API. So it's been renamed. It's now called the Open API specification, and you can check it out at openapis.org. There's also some really interesting tooling around it for clients. I personally haven't gotten to play with those yet, but it's another really cool thing that you can get out of this framework. So again, scaling an API is much more than just adding servers. You have to think about what it means to have many people both creating and consuming APIs. You want to make it easy to do the right thing and make it hard to break anything. So let's talk about technology transitions. Inevitably, you're going to release something that you wish you hadn't. In my case, I inherited an API that was 2 years old. And there are certainly some design decisions that I don't really think are the greatest. But I can't justify changing them because it would incur such a high cost to clients with very little benefit to them. So I sometimes think of the old serenity prayer. God, grant me the serenity to accept the things I cannot change, courage to change the things I can, and wisdom to know the difference. But sometimes there are changes that are breaking and they're worthwhile. So I'm going to share 3 stories about changes that were justified by security best practices, by performance, and by evolving industry standards. The first one is going from non-HTTPS, which I like to abbreviate as HTTP bang S, to HTTPS. So here's the problem. Fitbit Api launched 2011, and HTTPS at that time was not as prevalent as it is today. So it allowed both HTTP and HTTPS. Because at the time, pretty much only banks and online stores were using HTTPS. But now, thanks to Edward Snowden, we know that we shouldn't trust our networks, and that we really should have HTTPS everywhere. And it's now easier than ever to use, and the performance overhead has been minimized. We also knew that eventually Fitbit was going to move from OAuth 1 to OAuth 2, and HTTPS is a requirement for OAuth 2. So we figured while we're still supporting OAuth 1, let's get all of our customers to upgrade to HTTPS. It can't be that hard, right? You're just adding one little S to every single request. Find and replace, you're good to go. So we thought. So the first thing that we did is that we announced this change by emailing all of our developers we updated our developer documentation, we posted it in our developer forum, and we did this with 2 months in advance of this change. And we also announced something that we called a blackout test. We said in 1 month, as a test, we're going to turn off non-HTTP requests for 1 hour. What this meant is that applications had 1 month to add an S to all of their URLs, and then when we did this blackout test, they would have an hour to verify that they had removed all of the non-HTTPS requests from their application, to verify and have confidence that they had upgraded their app correctly. The other way of looking at this is you have 1 month to fix your app, otherwise we're going to break it for an hour. And no one wants to have a broken app for an hour. So we did this test, and we ran it, and we logged all of the requests that came in that were non-HTTPS. And then we individually contacted all of those developers who hadn't updated their app to let them know, hey, hope you noticed, but your app was broken for an hour because you haven't upgraded your app to use HTTPS. That got their attention. And then a month later, we released this change with pretty good success. Most apps actually did make it in time. So the lesson that I feel like we can take from that, one, start with HTTPS. There's no reason in 2016 to not use it. But you also want to make sure, if you have something like a blackout test, it enables developers to have confidence that a coming change that's going to affect them, that they've met all of the requirements, and that they're going to be okay once that change is fully implemented. So follow up with people after such a change. And these days, you should go further than just using HTTPS. You should really be looking at HTTP strict transport security, HSTS, as well as content security policies. These are like the next thing you should be doing with your API to make sure that there's no one between the server and your clients. Story 1. Story number 2. Epically broken webhooks. All right, so the Fitbit Web API has a traditional client request server response model that you find on most APIs. But we also have another mode, and we call it the subscriptions API, but it's now generally known as webhook APIs. So we have a lot of applications that want to stay in sync with Fitbit in real time. But a Fitbit tracker only syncs every 15 to 20 minutes, and they're all offset differently. So if an application wants to stay in sync with Fitbit, what some applications would do would be like, every minute, ask the Fitbit API, hey, do you have any more information? Do you have any more information? Do you have any more information? And usually the answer is no, no, not yet. Please stop calling us. So what webhooks allow Fitbit to do is for Fitbit to notify applications when there's actually new data. So we're not just wasting API requests going back and forth with no new data. And this means that clients have to actually create an API for Fitbit. So it's a reverse API. What we learned is that many apps were not very good at making APIs. It's hard, I get it. What would happen is Fitbit would send a request to those applications, and those applications would get that data, and then they would start processing that data, and they would go make other API requests, they'd go do stuff in their database, then they would come back to the request from Fitbit, and then finally close that connection. And we saw this behavior where we're transferring small kilobytes to applications, and the connection was being held open for minutes. And we're like, what is going on in these applications? It's only 20 kilobytes. That should be like that to transfer. So this would not be a problem if you only had a few applications that did this and only a few users of those applications. But in Fitbit's case, we operate at a very large scale. And we tell any app that has more than 1,000 users, which is a lot of them, that you should use the webhook model. It's far more efficient. So we have some applications, hundreds of thousands of users on them, and they have this very poor way of letting us notify them of when there's new information. And what ended up happening is that our servers that would send those requests, they were running out of open connections that they could possibly open. That's tens of thousands of requests concurrently. And the servers are just running out of connections because they're being held for so long. And this was causing us to stop delivering notifications in real time. Those notifications just kept getting backed up, and sometimes lost. So this was a huge problem for us. We knew we needed to fix this. So here's how we went about solving that. First, we reminded all of our applications of what a good integration should look like. An application should receive that webhook notification and then close the connection, like a proper gentleman. And then we're like, okay, what we're going to start doing now is that if you don't close that connection within 5 seconds, we're going to abort the connection. Now, in TCP land, if the person making the request improperly closes the connection, that's a really bad thing. So we thought that that would be enough motivation to get people to comply. But we couldn't just implement this policy overnight because that would have broken all of our apps. So we gave a 3-month timeline, and we announced that we're going to gradually shorten the time that we would allow these connections to be opened, right? And many apps were like, oh, cool, we get it. And they updated very quickly. But many other apps didn't. So as we started lowering this timeout, we started seeing more and more failures. And typically, applications would see, oh, wait, my application actually is not doing the right thing, and they would quickly fix it. But we started seeing a bunch of applications that were not fixing it. So now we have this other problem. We have unmotivated clients who are not fixing a problem that has the potential to take down our webhook service or delay requests to other applications that are doing the right thing. So how do we solve that problem? Well, we announced another policy change. We said that if a majority of the requests that we send to you in an hour fail by timeout, then we're going to stop sending requests to you entirely. And when we do that, we're going to send you an email automatically saying, hey, we stopped sending you notifications, here's why, and here's how you can fix it. The strategy worked really well. We got a very quick reaction. When those apps stopped getting those notifications, they knew they actually had to do something to fix that problem and to come into compliance. So today we send a ton of notifications very efficiently, and this is good for both Fitbit and the clients. And what we can learn from this is that when clients do something that threaten the availability of your API, you have to take action. And you have to explain to them why it is in their best interest to take action. Communicate your plan, adjust that plan as you get feedback and as you see certain behaviors. And remember that sometimes introducing a little pain may be the only way to get the outcome that you need. Don't want to use that often, but sometimes it's necessary. Story 3 is a story of OAuth. This has been a fun story. It's the one that we've most recently gone through. So again, when Fitbit created its API, it was before OAuth 2 existed. So like many other APIs at the time, we were using OAuth 1. But it had a few flaws. One of the biggest ones is that OAuth 1 doesn't have granular permissions. And with Fitbit, we have a lot of data. And some people consider that data sensitive, like my heart rate and my location. I could consider that very sensitive data, and it's different than my step data, or my distance data, or my calorie data. So OAuth 1 didn't have a way for us to deal with that. The other thing about OAuth 1 is it was created in an era when most API communication was done server to server, right? But with the advent of mobile applications, most API usage now is being done in distributed clients. So the code that we write is being run on computers we don't control. Well, the OAuth 1 security model doesn't really make sense in that world. And the other big thing is that with OAuth 1, it uses request signing. So there's a little bit of hashing and cryptography involved. And this would be fine if everyone went out and found a really great OAuth 1 library in their language of choice and used it. But instead, we had a lot of people who felt they needed to write their own OAuth 1 signing library logic. And this caused a lot of problems. OAuth 1 signing was actually our #1 customer support problem, which is a problem that can be solved simply by going and finding the best library for your language and just using that instead. But some people wanted to go it alone. So we knew we wanted to move to OAuth 2, and we also knew that there were some potential problems that we could see. So we released OAuth 2 as a public beta for 6 months, and before it would become a recommendation. And we learned a lot in that time, and we were able to adjust our implementation based on the feedback. One of the biggest problems we ran into is that OAuth 2 is a framework. It's not a protocol. So there's no one right way of doing things in OAuth 2. This is problematic. So how did we go about this? Well, my team, we went out and we studied tens of other APIs. We looked at their implementations of OAuth 2. What were the parts of the OAuth 2 framework that they chose to implement, and how did they implement it? Because we wanted the Fitbit API to be easy to use. We know that we are typically just one of many APIs inside of an application. And so if developers already have experience with OAuth 2 on another API, we want to be as similar as possible. Like a really bad example of OAuth 2 is Facebook. They implemented a very early, I just reached my 10,000 hand gestures for the day notification there. Facebook implemented a very early version of OAuth 2 that doesn't resemble anything like the final version of OAuth 2. Google, on the other hand, has adapted theirs over time, and it's very good. And one of the best that I've seen is Boxes, box.net, if you're curious about OAuth 2 implementations. Another area that we were going to focus on is that OAuth 2's granular permissions called scopes could be problematic. Because instead of an application prompt consent screen looking like, do you want to allow this application to access your data, yes or no? Now that prompt looks like, do you want to allow this application to access your step data, your heart rate, your location, your sleep data, yada, yada, yada. And we knew that this sort of consent screen could be intimidating to end users. We also wanted to empower users to not give all of their permissions that an app is requesting. So we designed this really great consent screen. If you authorize any Fitbit app, you should check it out. I'm really proud of this work. I think it's a huge win for end users. But it introduced an edge case for third-party developers. Because now third-party developers had to add a check to make sure they actually got all of the permissions that they requested. So it's something that we had to add to our documentation and adapt a little bit. Another area of that we knew would be difficult for apps was the refresh token process. So with OAuth 2, you have an access token. That access token expires. You get a new access token by making a refresh token request. And you get to make that refresh token one time. And so applications had a good concern. What happens if I make that request with a refresh token, then crazy things happen on the network, and I don't get the response back? Now I don't have a valid refresh token, and I don't have a valid access token either. My users are stuck. So one way that we worked around this is by implementing a 2-minute grace period. So applications can actually issue that refresh token, the exact request multiple times, and get back the same response each time within a 2-minute window. We're actually going to change this and do it even better. We're going to say, we're going to give you a new access token and a new refresh token, but we won't invalidate your refresh token until you actually use that new refresh token. So it's a really nice way of giving applications confidence that they're not going to lose a connection to a user's account. Another aspect is we had all of these OAuth 1 applications. Some of them had millions or hundreds of thousands of users. You can't expect an application to ask all of those users to go through the consent screen again to give them permission again. So we had to create an OAuth 1 to OAuth 2 migration strategy for applications that could seamlessly upgrade an OAuth 1 token to an OAuth 2 token. And that was something I'm really proud of that we got out there. Most applications upgraded users, and users didn't have to do anything. They had no idea that a major technology change had just occurred in the app. So today, it's easier and faster than ever for people to get up and running with OAuth with the Fitbit Web API, because OAuth 2 is just so much easier to use. And it's no longer the top customer support issue for our API team. And that's super exciting. We fixed the #1 customer support problem for us. So lessons I think that we can take from this, even significantly improved standards can have a high cost for clients. But the benefit to future clients is often justifiable. But when you do such a change, keep in mind about how much support work it's going to take to get that change rolled out. So there you go. I hope today that you'll leave with an understanding. We can actually get it to go. Some of the product strategy, that APIs can be used to enhance your product and sell more of your product. That you'll have a little bit more of an understanding with organization scaling, that developers can adopt user experience practices that are good as you scale. Especially when those customers are other API users. Try to develop empathy between developers in front and behind of the API. And lastly, technology transitions. How you can make a breaking change without breaking your ecosystem. It is possible. So what's next? Well, I now have 3 years of experience understanding the capabilities and the constraints of the Fitbit API. And now I'm going to start applying that understanding to fix some of the architectural problems that can only be fixed through a major versioning of the API. I don't yet know what it's going to look like, but perhaps in a few years you'll invite me back and I'll come talk about all of those things. I'd be really excited to share it with you. And thank you for inviting me to share my experience with you today. It's been an honor to be here in Brazil with you, and I'd love to take any questions.